it's just going to start in the highest priority queue. So every job that arrives is going to be put into the queue with priority 1. Now, so again, we're doing round-robin scheduling. So we're giving each job in priority 1, the priority 1 queue, a specified time slice. And what we're going to do is when a job's time slice expires, we're going to drop its priority 1 level. Now, if a job's time slice expires, now what's sort of the intuition behind doing that? What does it mean if a job's time slice expires and it hasn't given up the CPU? Yeah. Right, exactly. What that means is that it essentially used all the CPU you gave it and didn't do I/O in any of that period. So it's probably a good bet that it's a reasonably CPU-intensive job because it used up its entire time slice. Versus a very highly I/O-bound job is often not going to use up its entire time slice. So if instead, if you don't use your entire time slice, and you end up doing a context switch because your job made an I/O request, then we're actually going to increase its priority level. Of course, up to the top priority level, you can't increase past there. But that's how you're going to essentially shift jobs between the priority levels. If you use up your entire time slice, you drop 1 in the priority level. If you don't use your entire time slice, you go up. So the end result of doing this is that CPU-bound jobs are going to quickly drop in priority, and I/O-bound jobs are going to increase. Because if you have an I/O-bound job, then if it's in a lower priority at some point, then and it starts doing a lot of I/O at some point, then it's going to quickly release the CPU frequently, and its priority is going to start increasing. So it's going to be elevated to the higher priority levels. Any questions on roughly how that's working? So remember, the goal here is essentially we're taking all the I/O jobs, putting them in the high priority queues, CPU jobs are falling in priority, and then we're just executing round-robin scheduling on each priority queue. Yeah. I don't know about Windows specifically, but I mean, like Unix-like systems essentially do it essentially like this. So let's look at an example of doing this. So here we're going to have 5 jobs, or sorry, not 5, it should be 3 jobs, length 30, 20, and 10. The time slice is going to be 1 second for doing that round-robin scheduling. We're again assuming no context switch time. And for the moment, we're going to assume that they're not doing I/O. It's all CPU bound. And so, it's a multi-level feedback queue, so we have multiple queues. You could have any number of queues that you wanted. For this example, let's say we have 3 queues. So Q1 is the highest priority queue, and there the time slice is 1. Q3 is the lowest priority queue, and it has a time slice of 4, because remember, the time slice increases exponentially. So it's 1, 2, 4, 8, so on and so forth. So what's the first thing that's going to execute? So we have all 3 processes that are initially where? What queue are they in? Right. So initially we have 3 jobs that are all in the priority 1 queue. So for the first second, what's going to execute? What are we executing for the first time slice? Job 1. Right. So job 1 executes for the first time slice. And then what's going to happen after its time slice finishes? So it's doing all CPU, so it completed its time slice. So what happens? Right, exactly. So its time slice expires, and it's still doing CPU. So its priority drops to priority 2. So it moves from the first queue to the second queue. So that's the first time slice, which is 1 second. So then what happens in the second time slice? Yeah. Job 2 runs for 1 second, and then what happens to job 2? Right, same thing. Job 2 runs for 1 second, doesn't give up the CPU, drops down a level. So, and then similarly for job 3. So, we're essentially sketching out how this is working. The notation we're using here is, the main number is the job number. The subscript is the actual timestamp, and the superscript is the amount of time that the job is actually executed. So, in this example, this is saying, at time 1, after 1 second, job 1 has executed for 1 second. And then the next thing we do is, after 2 seconds, job 2 has just executed for 1 second. And at time 3, job 3 has just executed for 1 second. I know it's a little bit confusing. Does that notation make sense to people? You may have questions on essentially, you can use any notation you want, but for working out a problem with MLFQ like this, you're going to need some kind of notation, so this is what we're using. So you should at least understand how this is working. So that's after the first 3 seconds, and after the first 3 seconds, remember every job has dropped down in priority to the second priority level, priority 2. So what is the next thing that's going to execute? So remember, we're doing round robin in priority level 1, and now there's nothing left nothing left with priority 1. So what do we execute next? Yeah. Job 1, right. So we execute job 1, which now has priority 2. And how long are we going to execute that for? 2 seconds. So why is it 2 seconds? Right, because remember, we're now in the second priority queue, so the time slice is no longer 1 second, it's now 2 seconds. So we start executing job 1 again, because it's first in the job 2 queue, and we're going to execute that for 2 seconds. After 2 seconds, what's going to happen? Is it going to go down or up? Right, it's going to go down. Why? Right, again, there's no I.O. going on here. It's still doing just pure CPU computation. So it executes for 2 seconds and then falls again from priority level 2 to priority level 3. So after job 1 is done, then job 2 starts executing again and is going to do the same thing. Job 2 runs for 2 more seconds and then drops down to priority level 3, and then the same for the third job. So that looks like this. So again, just to review the notation, we have job 1 after 5 seconds, this is 2 seconds past the last thing. After 5 seconds, job 1 has now been executing for 3 seconds. Another 2 seconds pass in which job 2 is executing. So now job 2 has been executing for 3 seconds. Another 2 seconds pass, and now job 3 has been executing for 3 seconds. Questions on that so far? I want to make sure people don't get lost in the notation here. Okay. So now, after 9 seconds is executed, every process has run for 3 seconds. And what queue are all the processes in? Yeah, right. They've all exhausted their time slice when they were in priority level 2, so they've all dropped to priority level 3. So what's the next job that's going to execute? Yeah, job 1 is going to execute for how long? 4 seconds, right. Because again, the time slice is increased again. So job 1 is going to execute for 4 seconds, job 2 is going to execute for 4 seconds, so on and so forth. So, that'll look like this. After 13 seconds, job 1's been executing for 7 seconds, so on and so forth. And so what job is going to finish first? Yeah. Right, job 3 is going to finish first, because remember, job 3 has a length of 10. So on the next time through the round-robin sequence, job 3 is going to finish, which is going to be at time 32, because here we're doing again. Remember, the time slice is 4. So another time slice passes where job 1 executes, job 2 executes, and then job 3 executes. And after 3 seconds of executing, from 29 to 32. Here we see that job 3 didn't actually use its whole time slice because it only had 3 seconds of work left to do. So at time 32, job 3 has finished doing 10 seconds of work and is therefore done. And so now job 3 is removed from the queues altogether, and job 1 and 2 are now going to alternate, with 4-second time slices until they finish.